Good morning, everyone. Welcome back to Math 098. We are finishing week number 6, which is really exciting. Remember, we only have 15 weeks for the semester, so we're really trucking along, which is fantastic. Yesterday's class, we talked about graphing by plotting points. We learned that one of the best ways to do this was to first rewrite the equation in slope-intercept form, choose any two x values that we'd like, any two x coordinates, plug them into the equation and output your y coordinate, and then those ordered pairs represent the 2 points on that line that you would connect, of course, with a straight line. So what we're going to do now is we're going to look at a different form of graphing. We're going to look at graphing intercepts, graphing the x and the y-intercepts. But we're going to start off, sorry, I got to sneeze. We're going to start off by identifying where the x and the y-intercepts are. So as long as we can, oh man, I'm really going to sneeze. Okay. As long as we can identify and visualize where the x and the y-intercepts are, good morning, Riangia, no worries, then we can actually, that can kind of inform our mathematical process. If you can see where the x and the y-intercepts are, and you can think about, wait a second, what do those ordered pairs look like? Then you can say, oh yes, that's how you calculate it mathematically, okay? I need the visual and the calculations to link up in your minds. That's exactly what we're about to do. So let's take a look. So we're going to graph by finding the x and the y-intercepts. The first thing I wanted you to do, hi Doc, exactly. So the first thing I want you to do is to carefully look at this very first graph here in your notes. Okay? When you think of intercepts, I want you to think of where the line crosses or hits the x or the y-intercept. That's what I want you to think of when you think of intercepts. So for instance, I hope that it's very clear for you, especially in your notes. When I look at this line and I follow this line, right, I'm going to follow this until I hit the x-axis. Notice that my line hits the x-axis at this point right here. So I'm going to put a big old dot right there to identify that specific point. Carefully reading the graph and imagining that each of these represent one unit. This is going to be 1, 2, 3, 4. So my ordered pair is going to be 4, comma, 0. Right? I moved 4 in the positive x direction, but I did not move up or down because I'm located right here. My line hit the x-axis at the point 4, 0. Remember, every ordered pair is x then y, alphabetical order. Note that the point 4, 0 represents our x-intercept. That's really important to note. That point 4, 0 represents our x-intercept. If we follow that line, and we say, okay, well, I want the y-intercept, we're going to notice, oh, the line hits the y-axis here at this point. Carefully, I write down the ordered pair. So notice that I don't move an x, but I do move up 2 units. So the ordered pair here is going to be 0, comma, 2. Again, x, y. Every ordered pair is in alphabetical order. Yes, Kevin, that's exactly correct. So that point is 0, 2. This point represents the y-intercept, where your line intersects the y-axis. Where the line crosses the y-axis, that is where your intercept will be located. Okay, good morning, Ashanti. So I want that to make sense. I want you to recognize that, oh yeah, that should make sense. Where the line crosses the x-axis or where the line crosses the y-axis, that's where my intercepts are going to be located. What I want you to notice is that with an x-intercept, you only have an x value of a number where y is 0. And then with the y-intercept, your y has a value where x is 0, right? They can both be the same. So for instance, your intercepts can both be 0, 0. Let me prove it to you. If we turn back to problem number 2 from last class, notice that my x and my y-intercept are actually the same. You see this? I'm going to make a quick note. Right here, this means that the x and y-intercepts are 0, 0. And that's okay. That's not a big deal. It doesn't matter. We were still able to graph the line. Even if I said to you, hey, everyone, find the x and y-intercepts, you'd say, well, I mean, it's 0, 0. You would then say, okay, well, I know how to graph by plotting points, so let me find one more point on this line. And we did that by letting x was 3, or letting x be 2, or letting x be 1, right? As long as we have 2 points, we can make a line, even though the x and the y-intercepts happened to be the same. Okay? That's just an example of the fact that you can have the origin be both of the intercepts. Take a look at your second graph. We're going to do the same thing. So I want to follow it until it hits the x-axis, which is right here. So I'm going to make that pretty big. That represents our x-intercept. So our x-intercept is the point 2, 0. And let's label it x-intercept. Remember, it's not enough for you to say that the x-intercept is 2. That's like playing Battleship and you're like, A! And I look at you and I say, I'm not going to play Battleship with you anymore because you don't understand how to play, right? It's weird. It just doesn't make any sense. So going back to this, if you tell me that the x-intercept is 2, I'm going to say, that doesn't mean anything. That doesn't make any sense. I need a point on a grid. So you must say the ordered pair, 2, 0. Bam. That's the x-intercept. It's an actual point on the graph. Make sure that every time you identify points, that they're in ordered pair form. Otherwise, you're just spewing out numbers and it doesn't even make any sense. Okay, and I might laugh. All right, just saying. So there's your x-intercept. Let's follow it until we hit the y-axis. And it looks like we're hitting right here. So if we count, let's notice that we move 0 in the x direction, but then we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. So our y-intercept is 0, -8. And let's label that y-intercept. I know it's really hard to see that, Kevin. But I was trying to, get as close to as accurate as possible. So I would hope you agree that it crosses here at about -8. Kevin, it's okay. So basically, to find the x-intercept, notice the pattern, 4, 0, 2, 0. Oh, so regardless of what the x-intercept is, your y-coordinate always has to be 0. Right? Your y-coordinate will have to be 0. Now, the cool thing about this is we can calculate the y-intercept by setting, the x-intercept by setting y to 0 and then solving for the x-coordinate. So remember, your x-intercept is written as x, 0. It will always be x, 0. If you want to calculate the y-intercept, you're going to set x equal to 0 in the equation, and then you solve for the y-coordinate. So the y-intercept will always be written as the ordered pair 0, y. Always, 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 always. Okay? So if somebody said, my 2 intercepts are, 0, -5, and then 8, 0, you're going to say, well, this one is a y-intercept, and the second one is an x-intercept. You're going to be able to say that because you understand the way points work, and you also understand where these points are located. All right, so let me show you what it looks like to graph a line by finding the intercepts. When you see this phrase, finding the intercepts, please think of zeros. Okay? Please think zeros. Intercepts, zeros. Intercepts, zeros. So what we mean by that is we're going to do both of these things. If I want to find the x-intercept, y has to be set equal to 0 and we solve. If I want the y-intercept, x has to be 0 and then we solve. Check it out. So I'm going to start by finding the x-intercept, which means y has to be 0. I'm going to bring this in just a touch so it's easier to see. So I'm going to take my equation, and where I see a y, I'm going to replace it with a 0. We're literally setting y to 0. So we have negative 2x plus 6 times 0 is equal to 12. 6 times 0 is 0, that goes away. So negative 2x plus 0 stays a negative 2x. And then we divide by negative 2 because we already know, we're so used to saying as mathematicians, we need to solve for the indicated variable. In this case, we have to solve for x. So x is negative 6. This means that our x-intercept is negative 6, 0. And we would actually begin by plotting the point negative 6, 0. That is our x-intercept. And I can write that here again. The x-intercept is a negative 6, 0. So negative 6, 0, negative 1, 2, 3, 4, 5. Here's a negative 6, 0. Awesome. But once I find one intercept, it's really important to find the other. So for the y-intercept, we know that x has to be 0. So we are literally going to say, well, because x has to be 0, I'm going to plug 0 in for x. So now I get negative 2 times 0 plus 6y is equal to 12. Notice it's the same equation. I just plugged in a 0 for x. Negative 2 times 0 is 0. 0 plus 6y is just 6y. And then this time the indicated variable is y. So we must solve for y by dividing both sides by 6. That leaves me with y is equal to 2, which implies that the y-intercept is going to be 0, 2. Again, I don't know how many times I can emphasize this. You need to write your answers as ordered pairs, okay? Write them as ordered pairs. So 0, 2, 0, 1, 2, here it is. We're going to take our straight edge and we're going to connect the two dots, connect the 2 points. Draw arrows on either end, and voila, we have graphed our line by finding the intercepts. That's all there is to it. Plug in 0 for one variable, solve, there's your intercept. Plug in 0 for the other variable, solve, there's your other one. Okay? On your own, try number 2. You know how to solve equations using equations that have fractions. Don't lose that. So I'm going to give you 60 seconds. When you have your intercepts, type them into the chat. Let's see what you get, starting now. Okay, let's take a look at this. So some of you looked at this equation and said, oh, okay, so we have a fraction in here that's kind of, you know, a little annoying, blah, blah, blah. Doc, you asked a great question. The order in which you look for the intercepts doesn't matter, as long as you just find them both. So what I'm actually going to recommend is kind of going with what Doc says. Can we just find the y-intercept first? And why not? Who says we can't? So I'm going to start by finding the y-intercept. And we are going to do that by noting that in order to find the y-intercept, we know x has to be 0. So I'm going to take my 0, plug it in for x, so I have negative 1/5 times 0 plus 1. Notice that goes away. And I'm left with y is equal to 0 plus 1, which is just 1. So like that, I found my y-intercept, which is 0, 1. All right, so excellent work for everyone who put that into the chat. Remember to identify which one is which. So Ryan, excellent work identifying that the y-intercept is in fact 0, 1. So we're going to label it as such. Okay, there's my y-intercept. If I want to plot that right now, I totally can. 0, 1 is on the y-axis, so I'm like, yes, it's on the y-axis, so I know I'm doing this correct. Now, okay, so excellent, Kayla. Yep, x, then y. So now we're going to find the x-intercept. So let me just do a little dotted line to separate the page so you can see this. So the x-intercept we know is when y is 0. So I'm going to plug in 0 for y, and we have negative 1/5 x plus 1. Now, you probably looked at this and said, okay, well, you know what? The first thing I'm going to do is I'm going to subtract the 1. I'm going to bring the 1 over, and that leaves with negative 1 is equal to negative 1/5 x. The next thing you did was said, oh my God, okay, what do I do? Don't forget our strategies from Unit 2. When we have an equation that has at least one fraction, we are allowed to multiply every term in the equation by a common denominator. So check this out. If I multiplied both terms by the LCD, which is 5, 5 times negative 1 is a negative 5. 5 over 1 times negative 1 over 5, we can reduce numerator for denominator. So we're going to divide 5 out of each numerator and denominator. And 1 times negative 1x is negative 1x. See how easy that was? You multiply by the LCD to eliminate fractions. I love it. Divide by negative 1, and we get that x is equal to 5. So my x-intercept is 5, 0. And let's plot that. 1, 2, 3, 4, 5. Here's 5, 0. Take your straight edge. I'll reveal the work again. I just want to draw this in here. Connect the two, and then draw arrows on either end, and voila! You have just graphed the line by finding the x and the y-intercepts. That's all it takes. I don't want you to overthink this, and I also don't want you to forget your tools. Don't forget your strategies. You can definitely multiply by the LCD in order to eliminate fractions in an equation, okay? You can also do this in a complex fraction, but we have not seen that yet. And more than likely, the first time you'll see this is in Math 104, which is intermediate algebra, okay? So that comes later on. Good. I'm going to turn the page. Let's look at number 3. Notice for number 3 we have 4y minus 8x is equal to 0. So for the sake of making sure that we're not, spending too much time kind of playing around with things, I want to walk you through this one. I still want to find the x and the y-intercepts. So I'm going to start by finding the x-intercept. Again, it doesn't matter. It's up to you which one you want to find first. I'm going to find the x-intercept. We know the format for the x-intercept is that we don't know x, but we do know that y is 0. So I'm going to take this 0 and I'm going to plug it in for y. So I get 4 times 0 minus 8x is equal to 0. Notice 4 times 0 is 0, so 0 minus 8x is still negative 8x, and that's equal to 0. I am then going to divide both sides by negative 8, and if you punched into your calculator 0 divided by negative 8, it would not say error. I'm going to prove that to you. Some of you think that if you divide 0 by a number, you get error, but that's not true. That's only if you divide by a 0. So 0 divided by a negative 8 is simply 0. Take a look at the other way. Error, right? Undefined. So because the 0 is in the numerator, this is fine. 0 divided by negative 8 is 0, which means that the x-intercept is 0, 0. But guess what? That also means that the y-intercept is 0, 0. That's kind of a problem, right? So both of the intercepts are 0, 0, the origin. But we need to see a line. I can't just plot a point and say, okay, I'm done. That's 4y minus 8x equals 0. No, no, no. We now have to fall back on our first strategy for graphing lines, and that is graphing by plotting points. If we need another point and we're unsure of where it is, use your strategies. So I'm going to go back to the idea of graphing by plotting points. Okay, if we go back to the idea of graphing by plotting points and you look back in your notes, luckily I have the note pages here, notice step number 1, rewrite the equation in slope-intercept form. Then we choose any two values for x. The cool thing is we already have 1 point, so we just need one more value. So choose any value for x, plug it into the equation, and calculate its corresponding y, and then write that ordered pair and connect the 2 points with a line. So let's take a look. So I'm going to start by getting y by itself. So this is the term I want isolated. That means that negative 8x, it's got to go. So I'm going to add 8x to both sides. That leaves me with 4y. Notice these two are additive inverses, so they cancel each other out, leaving you with a 0. But 0 plus 4y is simply 4y, so that stays. Bring the equals down. 0 plus 8x is just 8x. I can write plus 0, but, I mean, come on. 8x plus 0 is just 8x. We're then going to get y by itself by dividing by 4, and we find that y is 2x. So this is when we say, okay, let's just pick another value for x. So how about I let x be negative 2, right? Just because I feel like it. I didn't have to. Some of you said 1. Some of you said 2 or 3 or 5. But I'm going to let x be negative 2, just because. So we have y is equal to 2 times a negative 2, which means y is equal to negative 4. So what that implies is that when x was a negative 2, y was a negative 4. So we're going to plot that point. Negative 2, negative 4. 1, 2, 3, 4. Take your handy dandy straight edge, and we're going to connect the 2 dots carefully. I like making sure that these lines are super straight because that helps us to identify additional points in case we needed to, or in case we wanted to, right? We want to make sure that we give ourselves options. And that is the graph of 4y minus 8x is equal to 0. Notice that I definitely found both intercepts, but I had to rely on my knowledge of graphing by plotting points in order to find one more point on the line so that I can actually make one. Your turn. Go ahead and do number 4. I would like both the x and the y-intercepts. When you calculate those, please share them with everyone in the chat. And let's see your work starting now. All right, excellent work, everyone. Let's take a look and see what these intercepts end up becoming. So we have the X-intercept, which we will calculate when we plug in a 0 for y. So we have negative 3 times 0 is equal to 4x plus 6. Negative 3 times 0 is simply 0. So we bring down the equals 4x plus 6. Thank you, Kayla and Keith. Or Doc. I called you Keith. Doc. We're going to subtract 6 from both sides. Negative 6 is equal to 4x. Divide by 4, of course. And that leaves us with negative 3 over 2 is equal to x. So for some of you, if you had written the x-intercept as negative 3/2 comma 0, that would totally be awesome. You can also write it as a decimal so that way we can plot it. So negative 1.5 would work as well, only because a negative 3/2 does result in a terminating decimal. So otherwise, we could say that the x-intercept is a -3/2 comma 0. So I'm okay with either representation. This is great. So -1.50, so -1.5, that's right about here in between those two grid marks. And then we're going to find the y-intercept. And we'll do that by making sure that x is 0 this time. So we have a -3y is equal to 4 times 0 plus 6. I'm hoping that by this point, this is starting to get this is starting to become more and more straightforward. You plug in a 0, you solve for the other variable. That's 0. -3y is equal to 0 plus 6, which is 6. Divide by -3, and we find that y is -2. So we plugged in a 0 for x, and we found that y was -2, and that represents our y-intercept. So 0, -2, we plot that point, and of course, connect them with a straight edge. Trying to make that nice and perfect here. Arrows on either end to show that they're continuing on towards infinity in either direction. And that is your graph. Perfection. So beyond using our strategies for graphing by plotting points and then graphing by identifying the intercepts, we actually have something called vertical and horizontal lines. Kevin, just to address your ordered pairs, remember they have to be ordered pairs. So when you found the x-intercept, which was a -1.5, you have to write that as a -1.5 comma 0. That is the x-intercept. It has to be an ordered pair. And then Kevin, in order to find the y-intercept, you need to force x to be 0. It should be 0 comma and then some sort of number, okay? So make sure you keep playing around with that until you start to feel comfortable with this process. But what I wanted to do was end today's class by looking at horizontal and vertical lines. I want you to see how straightforward identifying vertical and horizontal lines actually are. So again, I want to connect the visual with the equation so that it makes sense up here. If you can see it, you can write it, kind of thing. So let me show you what I'm referring to in terms of vertical and horizontal lines. So let's take a look at this first graph right here. Clearly, this is a horizontal line. All right. And Kayla, that's okay. As long as you're simplifying as you go through, that's perfect. And then Ria, I am totally comfortable with either or. The nice thing about this particular x-intercept is that -3/2 is exactly the same as a -1.5 because this is a terminating decimal, so I'm comfortable with either representation, okay? However, if this were something like -1/3 where it's 0.333333 repeating, then leave it as 1/3, but then try to get close enough to that point, or use graphing by plotting points to find an integer coordinate, okay? That means a positive or a negative whole number. Okay, let's take a look. So we have our horizontal line here, right? Vertical, horizontal. So what I wanted us to notice is I wanted us to write down the ordered pairs for these 3 points that I've identified. So if I start with the point furthest to the left, this is actually -1, -2, -3, -4, up 1, 2. So this first point is a -4, up 2. When I look at this ordered, or this point right here, the ordered pair pertaining to this point is 0, up 2. So 0, 2. And then when I look at this point, the furthest to the right, it's going to be over 2, up 2. Now I want you to carefully look at those 3 ordered pairs. -4, 2. 0, 2. 2, 2. Do you see how each of those ordered pairs all have the same y coordinate? I'm going to make a note of that. They all have the same y coordinate. That's pretty crazy, right? They all have the same y coordinate. Would you all agree with me that if they all have the same y coordinate, then this means that y is 2? Guess what? You just found the equation of the line. So I'm going to write below here the equation of the line is y is 2. The equation of that line, no joke, is simply y is equal to 2. The y coordinate for every single point on this line, and it doesn't even matter where you are. You could pick a bunch more points. You can pick every single point on this line if you would like. Every time you pick a point, y is 2. That is the equation. It's as simple as that. Y is equal to 2. Let's do it again. Take a look at this vertical line. And let's identify the ordered pairs that I've got here. So we'll find this one first. So -1, -2, -3, -4, -5, up 2. So -5, comma 2 is this first ordered pair right here. My second ordered pair is going to be -5, comma 0, right? Because I didn't move in the y direction, but I moved left 5 units. This ordered pair here is a -5, -1, -2, -3, -4, -5, -6. So this is -5, -6. What do you notice? Oh, each of these ordered pairs, -5, 2, -5, 0, -5, -6, they all have the same x coordinate. They all have the same x coordinate this time. So what that means, everyone, is the equation of the line is x equals -5. Yes, Ria, they all have the same x coordinate. Because they all have the same x coordinate and they're all on the same line, that means the equation of the line has to be x is equal to -5. Which means y could be any number, right? Look, y is 2 or 0 or -6. It doesn't matter. Any point you pick on this line, x has to be -5. But y could be anything. Anything, right? It could be any one of these points. But x has to be -5. So if it helps, I'm going to write xy over the ordered pair. I'm going to do the same thing for the first ordered pair in the first graph. xy, -4, 2, 0, 2, 2, 2. Hopefully that idea makes sense. So to summarize this, every horizontal line is of the form y equals b, where b is any real number. Every vertical line is of the form x equals a, where a is any real number. Check out number 1. -2x plus 3 equals 7. If you saw this equation, you'd be like, oh, solve for x. Right? Okay, so if we're going to solve for x, wouldn't you just subtract 3? You'd get -2x is equal to 7 minus 3, which is 4. And then you're like, I'm almost there. You divide both sides by -2, and you get that, well, x is -2. X is -2. Let's think about that for a moment. X is -2. Here's my first point. Do you agree x is -2 here? That particular ordered pair is a negative 2, 0. X is negative 2. Rhea said for the previous problem, same X. Okay, same X. As long as X is a negative 2, you can put any number you want in this spot. It doesn't matter. Any number. Literally. Pick one out of thin air. The constraint here is that X has to be negative 2. So I'm going to pick a 3 here, just because, again, I feel like picking a 3. Doesn't have to be. It could be 1, 2, 3, 4. It could be 0. It could be negative 1. It could be whatever you want. We already have 0, so we're not going to pick 0 again, right? You need 2 points to make a line that are not the same point. So negative 2, 3, 1, 2, 3. And now I can prove that X equals a negative 2 is a vertical line. So I'm going to connect these with a straight edge. Or with a straight line using my straight edge. Oh man, I tried to make that straight and then it went all crazy. There is my vertical line. And that is the equation, X equals negative 2. All right, take number 2 home. Bring that back with you on Monday. This is 1 over 7y plus 1 is equal to 0. I want you to solve that over the weekend. Bring that back with you on Monday. Beautiful work today. Wonderful, wonderful job. I hope you all have a fantastic weekend, and I will see you all Monday for week number 7. Bye.